All right, everyone, we're going to get started. We know more people are still dialing in, but we've got a lot of content to work through, and so let's jump right in. This is Jason Steinberg speaking. Thank you all for joining us today. I'm with Scannfly. We are excited to share with you about how you can fly drones for solar site surveying and 3D mapping purposes, specifically around trees and other forms of vegetation. We wanted to first thank our partners on this webinar. Brian Hayting at HeatSpring, our curriculum partner, and who's hosting our webinar today. Keith Perry of Hudson Valley Drones, who is Scannfly's hardware partner and a DJI dealer. And David Williams of Northwest Drone Pros, who we work with on behalf of customers in the Pacific Northwest. This webinar is being recorded and will be posted on HeatSpring's awesome curriculum site as a free webinar, as well as on Scannfly's YouTube channel. So let's jump in. We've got a fulsome agenda for the next 60 minutes or so. First, I'm going to provide a brief overview of Scannfly and how our platform works. Then I'll turn it over to David, who will walk you through the best practices for flying drones around trees. He has unparalleled experience in this area because every day he is flying around well over 100-foot tall trees across Washington State. And we've worked with David on numerous sites, so I think it's going to be a really interesting case study for you to listen to. After that, Keith will walk us through various insights on what hardware you'll need, including discussing obstacle avoidance, what happens when your drone gets stuck in a tree, which we don't like to talk about, but unfortunately does happen, and how to assess the damage. Then my colleague, John Novak, who's really the visionary of Scannfly's platform, will walk through 3 example sites with varying tree coverage. These are real examples permissioned by Scannfly customers. He will discuss photogrammetry, flight paths for each site, and helpful methodologies for 3D mapping. It's going to be a really great case-by-case example that you'll get to walk through with him. We'll also sprinkle in a couple of poll questions during the webinar so we can all learn from each other. And then lastly, we're going to conclude with a Q&A session. If you have any questions throughout the webinar, please post them in the chat box. Our team is already starting to organize some questions, so feel free to include them. And then we're going to open it up to all the presenters for Q&A at the end. We're going to try to achieve these minute parameters. If we need to go over by a couple minutes, we will. And again, all this will be recorded if you do have to run. Okay, so Scannfly was started to remove the inefficiency and human dependence in the solar workflow. Our team consists of nearly all solar professionals, so we've experienced a lot of these problems firsthand. These are things like climbing on roofs and walking fields or using tape measurers, which lead to a lot of on-site challenges. Satellite imagery and poor data create inaccuracies and change orders, and archaic shading tools are tough to use sometimes. Scannfly's vision is to streamline and automate as much of your solar workflow as possible to make it faster, safer, cheaper, and more accurate for your everyday project. We do this and we improve the workflow at Scannfly by leveraging our proprietary drone-based 3D modeling software. It helps solar companies survey and design projects more effectively. Scannfly software is used by solar companies all over the world, whether it's to create perfect arrays, shading analysis, sharing beautiful imagery, or exporting AutoCAD or SketchUp files. Scannfly customers are enhancing their workflows. We know many on the webinar, many of our customers are on the webinar today, and we just want to acknowledge them and thank them for their time and for helping us build the future of the industry. Just a bit about how Scannfly software works so we all have some context here. First, you're going to fly a drone and take pictures of the site's features. Then you'll upload those drone pictures to Scannfly software, which automatically stitches them together to make a 2-scale virtual replica 3D model of the property. It's the photogrammetry process, which John is going to dig into later on in the presentation. After that, you'll design and analyze your solar project. And from there, you'll be able to export a variety of files, including CAD files, shade reports that are bankable, sales imagery, and other things. We try to keep our software's outputs as portable as possible, which is the nature for these exports. Some basics on flying drones, just to set the table before David presents. We advocate flying in a point of interest or POI formation. It's the best way to capture obstructions and rooftops and other things where getting that correct angle will allow you to capture the vertical features of a site. It's how you make a really good 3D model with all of the height included, that Z-axis. You can see the facades of the houses and you can see those sides of obstructions. And again, that's how you really create good 3D models. Having good overlap is also key. We recommend roughly 80 to 90%. We have a ton of resources on our website. If you go to the homepage, there's a resources tab. I just want to call out two in particular. If you scroll down to the middle of the page, we've got an extensive guidebook on flying drones for solar. There's also a link to our YouTube page, which is where we have a lot of tutorials. So that's some really good reference points for anywhere that you're getting started on your journey with integrating drones into your solar workflow. Scannfly is also the continuing education provider for NAPCEP. We do a monthly webinar on drones, 3D mapping, and LiDAR. Our next session is on August 19th. Again, these are offered monthly. And the course is also available in recorded fashion on HeatSpring's website for free. All right, that's enough on Scannfly. It's most important to get to the content here. I just want to first, again, and thank HeatSpring. HeatSpring offers more than 160 courses, including NAPCEP training and a 12-week drone pilot bootcamp that takes you through the Part 107 license and onto flight skills, data gathering, data prep, and report production. They have a phenomenal library of curriculum covering a massive diversity of topics. So I definitely recommend going to HeatSpring and checking them out after the webinar. Brian, who leads the HeatSpring group, and their whole team have amassed an amazing library of knowledge there. So again, huge thanks to the HeatSpring team for helping us put this together and managing the technological side of everything we're doing today. And so just want to really give them a strong plug. All right, now to the good stuff. So first we have our first poll for the webinar. So to kick off, I'd like to find out from the group, what type of drone are you flying? So if the group can all answer, we're looking at, Phantom series, different types of Mavic drones, whether it's the Pro or the 2, the Mavic Air, the Mavic Mini. And then recently there's been promotion by Skydio. Unique was a drone that was popular. Some people have other preferences. And then lastly, if you don't have a drone, that's great to find out. So if you can fill out these questions, we'll let everyone respond. We're going to give it a couple more seconds. We got a lot more responses coming in. What we've learned, and I know Keith will touch on it, is people use the drone, different size drones or different types of drones for different purposes. Perhaps some people use the Mini for more marketing purposes, whereas the Phantom series, at Scannfly, we use that for a lot of beta testing as more of a workhorse drone. A lot of our customers recently have been considering the Mavic series, though. So we'd love to get a sense for everyone with what drones they're using, and we'll go from there. All right, we'll give it another couple more seconds, and then I'll have Brian close the poll. All right, let's see what the results are. Put this in frame. All right, so it looks like we've got a decent diversity, but at least about half between the Phantom series and the Mavic Pro or the Mavic 2. That's pretty consistent with what we're seeing from our customer base and what people are using reliably for site surveying and 3D mapping. Interesting about the Air, we know the Air 2 has been popular. Different books have referenced for the other department, the Autel drone, which is increasingly interesting. It's also notable that Skydio only has one, but they have had a lot of promotion recently. This is very helpful results, and hopefully this is informative for those who don't have a drone with what options to choose. Keith will be walking through information after David, but he is Scannfly's DJI dealer, and we can hook Keith up with you if you want to ask specific questions. All right. Okay, so let's get into David's presentation. So Scannfly is excited to have David Williams of Northwest Drone Pros walk us through his experience as a pilot in the Pacific Northwest. David will discuss how to fly drones around massive trees, what to consider for seasonality, types of trees, and flight automation. A bit on David. He is an FAA Part 107 certified drone pilot, the owner, operator of Northwest Drone Pros. He also currently works as a technical advisor at the PACCAR Technical Center. His previous experience includes positions as an automation technician, setting up communication equipment in the oil fields of Colorado, and as an equipment engineer at Tesla Motors in Silicon Valley, automating processes in the Model S and Model X lines. David holds degrees in instrumentation and operations management and is a licensed electrician. He's also has always been fascinated with flight, and when presented with the chance to combine a hobby and a business, he went for it. And so now David also flies drones for a bunch of Scannfly customers around the Pacific Northwest. I'm going to turn it over to David and let him walk through the presentation on his side.
Awesome. Thank you, Jason. All right, let's get to it. So Washington is a unique area because we have such an abundance of trees. It's not rare at all for both evergreens and deciduous trees to reach well over 100 feet. Deciduous meaning trees that shed their leaves annually, and evergreens, of course, retaining their leaves and colors throughout the year. Now, if your $2,000 drone gets stuck in a 100-foot tall tree, not only will it be near impossible to get it out of the tree if it gets stuck, if it falls, it's either not going to be in the greatest shape or it's going to be completely destroyed. And then, of course, you won't be able to recover your images for the survey. So today I'm going to give you a few quick tips to help you get great imagery and also keep your drone from harm. Okay, first I'll start with some of the best practices I've identified through experience flying around and, of course, crashing into trees, which I've done many times. So here are some of my before flight tips. And before I start, I also want to let you know that my colleague Keith Perry, he's going to be going into this in even greater detail in the next module in just a few minutes. Okay, number one, swap out memory cards. So if you're surveying multiple locations in a day and you crash into a tree or you lose the drone with the previous survey's images on board, you'll have to return to the survey location again and get the images. And it could be foggy when you return or raining. So I just as soon have multiple memory cards. They're cheap and you swap them out, and that way you don't have to worry about returning if you do go ahead and wreck your drone. Number two, have spare props. So they're about $30 depending on which model you're flying. But if you hit something and you damage the props at a location and you don't have spares, you'll be out of luck on getting the survey done that day. And they don't sell props at the corner store, so you'll have to go to Amazon, wait a couple days, and then have to drive back to that location, which can be far at times. And the county I live in, there's islands and just there's long trips sometimes. And this has happened to me where you damage a prop and then you're pretty much screwed for the next couple days. So prop guards, I definitely recommend prop guards. They're about $30 as well, and they protect people and objects from the spinning propellers. And they also improve their flight safety because they can prevent minor collisions, such as a small tree branch bringing your drone down, which also has happened to me many times. So if you just invest a little bit in the prop guards, you can protect yourself. Now this one's a little more costly, but it's certainly worth the investment, a backup drone. I always bring a second drone because you never know if there'll be an equipment failure or it'll ask for a software update while you're on the site. And if you don't have web accessibility, you won't be able to do that and the drone won't take off. So personally, I use the Phantom 4 as my backup, and I use the Mavic 2 as my main drone. Okay, GPS mode. Now, do not take off until you're in GPS mode. And I think Keith will agree with me on this. I fly exclusively in GPS mode, and with DJI drones, you'll know you're in GPS mode because the upper left portion of the display will turn green. And it will say GPS on the display once the drone is locked in. And I think that requires around 9 to 12 satellites, and the satellites are how the drone positions itself. The drone will then automatically lock in its return to home setting, which means if the battery life gets low or there's communication issues, it will return to where it took off from. I never ever fly in ADI mode, which is the default mode. If there's not enough satellites or you're in a very remote area, sometimes it'll take a while to lock into GPS mode, but I will not take off if it's not in GPS mode. ADI mode is short for altitude mode, which it means the drone will maintain a specific altitude, but not position. That means the drone will remain at the same height, but it'll drift around in the wind. And I certainly do not recommend this when you're flying around 100-foot swaying trees. And when it's in ADI mode, you'll see the drone, it acts pretty erratically, and it's not a comfortable feeling in my experience. Okay, RTH settings. So you want to make sure your RTH or return home setting is set higher than the surrounding trees. The way that return home works is when the battery life gets low or the drone loses communication, it will attempt to go back to where it launched from. It will first elevate to a height set by you, then move horizontally towards home. So if obstacle sensing is off, the drone could raise up to its RTH height of say 80 feet, then start going home. But if the surrounding trees are 100 feet, then it's going to crash. Now, if obstacle sensing is on, there's the potential it may sense the tree and stop, but the battery life could be so low that it can't make it home and will fall out of the sky. Okay, now that we've covered some of the before flight tips, let's move to some recommendations for before and during flight. First, where to stand. So when I arrive on a property, the first things I'm looking at is my flight paths and my foot paths. I want to maintain a visual line of sight of my drone at all times. So I need to know where to be to see it as I navigate it. So if there's a gate that needs to be opened or I can't access one side of the property, these are all things that I want to know before I take off. In my experience, it's not the most comfortable feeling watching your drone go behind a 100-foot plus tree in POI mode, which we'll discuss later and Jason mentioned earlier, especially when there are most likely other trees behind it. So each property is of course different and unique, but you want to put yourself in the best position to view your drone at all times, even if it requires you to land to reposition yourself. Generally, you'll be flying 2 flight paths, which John's going to be discussing later, a detail and a context. The context flight is the higher flight, and it's the higher altitude flight, and it's usually around 70 feet, unless, like in my circumstance, there are trees higher than that, which most likely there are here in the Pacific Northwest. And the detail flight is usually about 10 feet above the roof line. So you just want to map out your 2 flight plans in your head and know for the context flight that with the camera angle needed, the full point of interest in frame and 100+ foot trees, you're going to need a decent diameter flight path. I usually fly the context flight first because it's at a higher altitude with a greater chance of collision because of that altitude. And there's also temporary loss of line of sight, wind, and tall swaying trees. Now there are a few things to consider when the drone is airborne. You have your camera angle, is the point of interest in frame, am I taking pictures of the right overlap? And sometimes battery life can also come into play. So I'm able to relax a bit after the context flight is finished because it's the most dangerous one. Now for the context flight or the higher altitude flight, the best position is wherever you can keep your drone in your line of sight. We're most likely not going to be able to follow its flight path on foot because of the large diameter of the flight path and obstacles such as other properties or foliage that it'll pass through. For the context flight, the first thing you want to do is fly the drone over the tallest tree to determine what flight altitude to set. So to me, that's the most important thing. I immediately show up, fly to the tallest tree. Then once you've cleared the tallest obstacle in the area, you set your flight altitude above that, and then you'll have peace of mind knowing that you're not going to hit anything when the drone is in point of interest mode. This is also helpful to determine what type of winds exist at the altitude before you start the actual survey, because when you get up above those tall trees, obviously the wind is a lot higher. Okay, now for the detail flight or the lower altitude flight. If you can, stand directly beneath the drone or as close as possible. I find depth perception to be much more acute. You only need to worry about obstacles, in this case branches and leaves, on one plane, whereas standing to the side and maneuvering the drone horizontally is harder to delineate both the vertical and horizontal planes. From the 2 images I provided, you can tell how hard the depth perception becomes when looking horizontally at multiple trees. The same with the picture on the right. It's nearly impossible to tell which branches are closer or farther. And by standing beneath the drone and using the sky to silhouette the trees, it's much easier to delineate the true edge of the tree's profile. In the detail flight, you wouldn't be flying this close to a tree that would affect the solar array of the property you're surveying, because in that case, you would need the whole tree in frame, but often you'll need to fly that close to other trees around the perimeter of the survey. So trees that won't be in the survey, but they're around the edge, around the perimeter. All right, as I mentioned earlier, the 2 types of trees are deciduous and evergreen, and each have their own unique challenges. Deciduous trees are more likely to be affected by wind in my experience, and with smaller branches and leaves, it can be harder to see the danger even when the drone is 10 feet above the roof line, and most certainly so if it's 70 feet above ground level. So these are the things you want to be aware of. We've all seen trees swaying in the wind, and in my experience, deciduous are more likely to have a greater amplitude of sway. And the higher you go up, the more this becomes true. Deciduous trees I know pose additional challenges to modeling because they don't retain their leaves throughout the season, so the shade analysis will change throughout the year. When it comes to flying around them in months when they have no leaves, you need to make sure to get the whole tree in frame so the model is as accurate as possible. Because of their sparseness and lack of density in the winter, they can sometimes be overlooked as an impact to the model. Now, evergreen trees, which obviously in the Pacific Northwest, we have an abundance of these. Evergreen trees have a much higher wind resistance and are less likely to sway at the amplitude seen with deciduous. So I feel much more comfortable getting the drone close to an evergreen tree, and then even occasionally splitting branches when necessary. But because of their height, the fact that once you breach them, wind speeds are always higher, and keeping your line of sight on your drone is much harder because of the density of their profile. So they're also a bit challenging. But obstacle avoidance is much more likely to see an object with the robustness of an evergreen because of the density. When it comes to flying around trees in different seasons, again, being located here in the Pacific Northwest, anytime it's not raining is a good time to fly. But my recommendation is to always check the weather before driving out to a survey. Having to cancel after arriving and then return later, it's a big waste of time. And this has happened to me many times, especially early on in my career for flying for Scannfly. When it comes to time of day, now my specific area is also prone to fog, which is often at altitudes lower than the trees. So the fog can be hard to predict, but when you have trees that are higher than the fog, then you're not going to be able to fly that day. So I like to survey in the afternoon when the fog is burned off. Too bright a sun can also pose issues, especially with a white roof, but fortunately for us in the Pacific Northwest, that's rarely an issue. But when it comes to time of day, flying surveys is of course very dependent on the area that you're flying in. There we go. So point of interest. So Jason and I both mentioned this in previous slides. It's a tool that will make your survey life much easier. The way it works is you set your point of interest and the drone maintains the speed, altitude, and circumference set by you. If you have obstacle avoidance or advanced pilot assistant software, you want to make sure it's enabled. So POI it's very intuitive and it can be set up in seconds. And I'll take you through the steps here. So one, and these are the steps for the DJI Mavic 2, the Mavic series, or the DJI series. They're all a little bit different, but it's basically about 4 steps to get you in there. So this is the Mavic 2 again. So first you're going to press the flight mode button on the left, which you can see highlighted there in red. Then step 2, you're going to select the point of interest as your flight mode. And then the POI flight mode display will pop up. And then once you're at an altitude higher than the tallest obstruction or tree and the full survey subject is in frame, using your finger, you're going to drag the square around your point of interest and press go. At this point, a warning will pop up notifying you to not operate the area or the aircraft during subject position calculation. And this usually takes a few seconds while it's getting its bearings. After that, you can adjust your radius, height, or speed if necessary and begin taking images. Now, for any reason you need to exit this mode, just hit the red X and the drone will hover in place, which sometime when I get uncomfortably close to a tree, you abort, and pressing the red X will just get you right out of there and the drone will just hover in place. Okay, you have a lot of things going on. So when the drone's in the air, you're watching your $2,000 drone, you're making sure the camera angle is right, you're checking that the whole point of interest is in frame, you're taking a picture every 2 to 3 seconds, you have trees swaying that are over 100 feet tall, the neighbors want to see what's going on, dogs are probably barking, which happens to me all the time, they don't like drones. So it's best to be aware of the dangers that trees pose and have everything set right before liftoff. Now, I hope I was able to give you some useful tips to keep in mind when flying around trees. My presentation was mostly about protecting the drone, but the alternative is going up on the roof, of course, and risking injury. And obviously, the more times you go up on the roof, the more likely injury is. So it's better the drone than you. And yeah, hopefully my tips will help you protect your drone.
Awesome. David, thank you so much. We're now going to move to our second poll question. How do you fly your drone? And so we're really here looking to understand, are you doing it mostly automated or are you looking to do it manually or not? So the options are always automated, sometimes automated. You prefer to fly manually or you just fly up in the air, take a marketing photo or quick video and land it. So we're trying to get a sense for how the group flies their drone and their comfort level with different modes. Give it a couple seconds for everyone to fill out this poll question, and then we'll turn it over to Keith. From the Scannfly perspective, I would say the majority of customers fly in full or partial automated flight modes. There's preference to, but we do see increasingly more customers fly manually, especially when they're around trees, for that control that David just alluded to. We also see the quality of imagery not be more towards one versus the other. We see actually some of the best 3D models created when flying manually. Now, those are people who have more expertise and comfort flying, but there isn't one lone solution for flying when it comes to 3D mapping in general, or for Scannfly in particular. All right, we'll give it a couple more seconds and then we'll close the poll. Okay, Brian, whenever you think the numbers are slowing down, we'll share the results. Okay, let's take a look. So how do you fly your drone? We've got about 20% always doing it automated, about half the group doing sometimes automated, and about a quarter doing only manual flights. So this is an interesting diversity here. And it's great to see that there's an increasing growing number of people who are sometimes or manual, which means that a lot of people are flying to some extent not fully automated, which from our perspective, and I probably can speak for my colleagues on the phone, it's better to know how your drone works than just to hit the button and let it go. And that's what we believe, and that's what we try to practice and to teach. So interesting results, but not entirely surprising. Thanks everyone for sharing your responses. Okay, go to our next presentation. So I'm now excited to introduce Keith Perry of Hudson Valley Drones. Keith is Scannfly's official hardware partner. For any of our customers on the call or anyone, any solar companies out there, if you have questions on hardware, Keith's our guy. We're happy to make an introduction. Keith Perry is the owner and lead drone operator of Hudson Valley Drones. While operating in the UAV space for nearly half a decade, he's built and maintained a successful drone services company in upstate New York. Prior to his emergence in the UAV market, he pursued and operated successful ventures in HVAC and in the insurance industry. In addition to holding a bachelor's degree in criminal justice from John Jay College, Keith is also a Part 107 certificate holder and a certified level 1 SCOAS thermographer through FLIR's ITC. So if there are any thermal questions, we'll direct those over to Keith, and perhaps David has some answers as well. He has extensive experience operating the Inspire 2 and the Matrice 210 platforms with both RGB and thermal sensors, and is proficient in precision mapping using ground control points and data processing and drone deployment Pix4D. I'm going to turn it over to Keith, who is going to walk you through hardware considerations and many other things.
Thanks, Jason. Hi, everyone. As Jason said, my name is Keith Perry. I'm the owner and lead drone operator at Hudson Valley Drones. It's nice to meet you all. We partner with Scannfly to help place their customers, help them determine what is the best hardware option and then place them or procure that hardware option. It's important to recognize that we all have different workflows, and while we may be using our drones, with Scannfly's platform, our needs may change based on what exactly or what else we do with the drone. Today, we're going to talk about those considerations that an individual or an organization might want to take into account when you're selecting a drone. And we're also going to discuss what you should do if you have the unfortunate experience of crashing your drone into a tree. So before we go into more detail, I think it's important to remember that your drone is a tool, right? It's a tool to help you in the survey process, just like your tape measure is a tool to help you measure, right? Similar to the way in which you wouldn't walk into Home Depot, buy a saw, and call yourself a carpenter. Just buying a drone won't necessarily yield the best results as far as a survey, right? It's important to make sure you have the right equipment and that you've practiced with the equipment and that you've become familiar with the equipment after purchasing it. So we're going to break down the hardware considerations into 4 categories: flight platform, camera quality, obstacle avoidance, and remote controller capabilities. Today we're going to focus mostly on DJI product offerings, but it's important to recognize that there are other options out there, and there are other considerations other than these four, but we've narrowed them down to these because I think they're the most important. So the first thing we're going to touch on is flight platform. The flight platform refers to the app or the software that you're going to use when you conduct your flight operations. Often people don't take this into account when they're selecting their drone for purchase. And, I think it's important to take it into account before purchasing your drone, because if you plan on using Pix 4D, but you purchase a Mavic Mini, they're not going to be compatible and you've just wasted $500 or more. So we want to make sure you're making the right decision in the first place and being as efficient as possible with your purchases. All drones offer a native flight platform, whether it's DJI Go or DJI Go 4, or more recently DJI Fly. And these platforms are used for manual flight and also for assisted features like the point of interest mode, like David talked about before. But there's other apps out there like Drone Deploy, Pix 4D, Ground Station Pro, Litchi, that can be used for other autonomous flight plans. Each have their own niche, so it's important to research them beforehand and determine which one would be a best fit for your workflow. The next consideration after the flight platform is the camera quality on the drone. Most drones nowadays, let me take a step back. Some drones, the Inspire platform, the Matrice 210 platforms have modular payloads, so where you can switch your camera depending on the application. The prosumer and consumer models, the Phantom series, the Mavic series, and the Air offer a camera that's not modular, so it's important that you make the right decision in the first place. Resolution is one of the most important factors. We typically don't recommend a sensor less than 12 megapixels, but that tends to be the industry standard nowadays. So if you're using a relatively modern platform, it's not typically a factor. Another important factor is the type of shutter on your camera. A mechanical shutter can often produce a more crisp and accurate image versus an electronic shutter. But in certain applications, it doesn't necessarily make a difference. So again, that's important to discuss and explore as far as what's right for you and your organization. Other considerations are your field of view, which is the angle at which, how wide of an angle you can see with the camera, and dynamic range, which is defined as the range of colors that you can see under a set condition. So obstacle avoidance is another hot feature, and it's been showing up quite frequently. Most drones now, I would say almost all drones now, have obstacle avoidance and obstacle detection to some degree. Obstacle avoidance allows for the detection and or avoidance of obstacles using visual, infrared, and other kind of sensors mounted on the drone. Here's an example of the Mavic 2 Pro specifically. It's got 6 degrees of obstacle detection. You'll see on the front, on the rear, both sides, the bottom, and the top. That's super beneficial, especially when you're operating in point of interest mode around trees, because it can help you with your situational awareness. As David said before, right, nothing beats visual line of sight, but obstacle avoidance and obstacle detection can be a tool to assist in not getting your drone stuck in a tree. It's important to be aware of the type of obstacle avoidance your platform has and the way that it operates. As we saw on the last slide, the Mavic 2 Pro has a 6-direction obstacle detection, which means an obstacle from nearly any angle will be detected. The same goes for the Phantom 4 series, with the exception of some top-mounted or obstacles that might be coming from the top. But if you compare that to something like the Mavic Pro, specifically in this image, right, you can see the lateral sensors on the Mavic 2, which is on the left, but they don't have it on the right. So if you're operating in point of interest mode and you don't have that detection and that assistance, you can find yourself parked in a tree quite quickly. So the last consideration we're going to talk about here is your remote control. Typically, DJI platforms come with two options, a standard remote controller and a smart remote controller. The standard remote controller relies on a third-party screen to be used, whether that's your iPhone or your iPad or a DJI display. It's beneficial because it comes at a lower upfront cost and it's compatible with most devices. It is also beneficial because you can use third-party apps on a standard remote. One drawback is that it's notoriously difficult to use an Apple device or even an Android device in a really bright sunlight situation. So that can cause another challenge when operating your drone. Now, the smart remote is a more recent addition to DJI's product lineup. It features a built-in display, which is super bright. It comes at a large upfront cost, but it's unparalleled in viewability on a bright day. A disadvantage is that it lacks most compatibility with third-party apps. So generally speaking, you're stuck with the proprietary DJI flight platforms. Now, that's not necessarily a bad thing, depending on what you're going to be using it for, but it's worth exploring before making that decision. So I know David touched on this before, but I think it's important to touch on some helpful accessories and other things that we might recommend with your purchase to get the most out of it. The first and most important addition, in my opinion, is going to be additional batteries. With any drone, I mean, 25 minutes or so is going to be your max flight time, even less depending on the conditions. So it's important to, and we recommend having at least 3 batteries total. That gives you the opportunity to go to more than one job site any given day, or to allow you to redo a flight if something's gone wrong. It prevents you from rushing when you're flying and gives you the time to not make mistakes. A close second to the batteries would be a hard-sided carrying case. I'm also a big believer in that. It serves 2 purposes. First of all, it protects your investment. If you've just spent $2,000 on a drone, you want to make sure that you want to make sure you don't crash into a tree, but you definitely want to make sure it's not bouncing around in your trunk and getting beat up. But more importantly, I'm kind of a believer that perception is everything. If you show up to a client's house with a soft-sided case or your drone in its cardboard box, they're gonna immediately be like, what's going on here? What is this? This person's obviously not experienced. So it says a lot to show up in it with a hard-sided case, with everything neatly packed in and protected. And I think it's a good image for you and your company ultimately. Other accessories I'd recommend would be a car charger, spare propellers, a charging hub for multiple batteries, propeller guards, spare SD cards. Those are all great features. I can't reiterate enough what David said. Use a different SD card for each flight, because if you crash or something goes wrong, at least you'll be able to salvage the data from the last flight. So now we're going to talk about what happens if you crash your drone. It happens. I've gotten my drone stuck in a tree. I'll admit it. It's a really frustrating experience and creates super high anxiety, but it's important to, manage it and deal with it as effectively as possible. The first thing you do is turn off the drone, turn off the propellers. I've seen people in like a panic try to grab the drone and try to pick it. That's a terrible idea. You can hurt yourself. After turning off the drone, you're going to evaluate the crash site for any damage that might have been caused by the drone, tree branches, power lines, right? A shingle on the roof, anything like that. Just make sure it's not a dangerous situation. Retrieve the drone, remove the battery, put it back in your case, try to collect everything that you can. Evaluate the damage. So then take a look at your drone, right? Are the damages superficial, or are there just some scuffs in the body, or is there really some serious issues? And then finally, you're going to want to document the damage, take photos of the drone, the crash area. If you cause damage to something else, that's going to be important to provide to your insurance company, but also to fill out an accident report if that's something that your company requires as part of their workflow. Now, being stuck in a tree isn't as bad as crashing, I would say, but it's still a really frustrating situation, and probably more common than crashing. So like the first and most important thing to do is locate the drone. if you're following the rules and you're flying within line of sight, it shouldn't be too far from you. So you should be able to locate it pretty easily. But if you've got a flyaway situation and for some reason you can't locate it, spend the time to find it. The drone should still be flashing because there's probably going to still be some battery life in there, so that can be helpful. But find the drone and then mark the location somehow, whether that's dropping a pin on your Google Maps app or taking down and wherever it is, somehow document that location. Make sure there's not a risk of the drone falling out of a tree and hitting someone. Take the time to secure below it. Use cones, use caution tape. If you don't have that, have someone stand below it. I mean, if it's in the middle of the woods and there's no chance that it falls on anyone, that's one thing. But, the only thing that's worse than getting your drone stuck in a tree is having it fall and hit someone. Like, that would be terrible. If you feel like you can safely retrieve it, give it a try. I've seen people use poles. I've seen people climb trees. Personally, I'm not a tree climber, and I wouldn't risk you getting hurt by doing it. If you can't get it on your own, contact a tree service, whether it's a tree climber or an arborist. A lot of times they'll be able to climb the tree, or if they can't climb it, they can go up in a bucket truck. It might cost a couple $100, but it's good to retrieve the drone, get it down, and get it back, and hopefully in pretty good shape. So once you've been able to retrieve the drone, you're going to want to inspect it for damage. Remove the propellers, take them in your hands, check to make sure they're not cracked, bend them a little bit, make sure they're still structurally sound. If there's any scuffs or anything like that, you can replace them. It's a really inexpensive preventative fix. Spin the motors, make sure there's nothing grinding in them. Check the arms, the camera, the landing gear, the battery, the lights. Check everything for damage. Make sure there's nothing that's going on with it. If all seems good, test the drone in a controlled location. Don't crash the drone at someone's house and then leave. Don't crash the drone at someone's house and then try to fire it up and fly it right there. If there's something wrong with it, it might crash again. And the only thing worse than crashing is crashing again in front of a client. It's a really bad look. Test all the features, simulate a site visit, even give yourself some time to cool down. And if there's any visible damage, contact DJI or a local repair shop and get it fixed by a professional. A few notes on repair shops. Generally, I'm a believer in sending it back to DJI or an authorized repair shop, but sometimes that can be a challenge. Sometimes there's a lag when it comes to DJI. Sometimes they're backlogged. I know with the whole COVID crisis, they were shut down for a while. Sometimes there can be a language barrier. They're a Chinese company, so sometimes dealing with tech support can be a little bit of a challenge. But if you can, send it back to DJI. If you can't, you have a local repair shop, go to them too. But ultimately, what I encourage people to do is do what you feel most comfortable with. It's a stressful situation. And if you can find someone good that you like to work with, capitalize on that and work with them. So as we wrap up this section, there's just a few points that I want to reiterate. Find the balance between features and cost on your aircraft. Sometimes you can have it all and sometimes you can't, and that's okay. There's always room to improve in the future and make an investment. The cheaper option isn't always the cheaper option. To spend less as far as an upfront cost might be great as far as the short term, but your deliverables might suffer long term. And we're here if you have any questions. We've made a lot of mistakes and learned over time. And if you can learn from us and we can shed some light on the questions that you have, we're happy to do that. Thank you.
Awesome. Thanks so much, Keith. That was very insightful. We're going to move to a poll question now. Third poll question: what data capture app do you use the most? So Keith referenced a lot of these on his prior slide, but I'll just reiterate them again. For capture app, we've got the Pix4D capture app, Drone Deploy, DJI Ground Station Pro. There's a bunch of other DJI apps that you might use, or other. So we'll keep this open for a couple of seconds. Just quickly respond to which capture app you use the most. For Scannfly, we typically see people flying with the DJI apps to leverage the POI modes that both David and Keith have referenced. For larger scale sites, both Drone Deploy and Pix4D have been useful for their rasterized or grid pattern formations. So it tends to be what type of site you're flying at or the size of that flight, but for our customers, what we're typically seeing if you're doing POI, you're using the DJI apps. Cool. So Brian, if you want to give it a couple more seconds and then we'll open up the, we'll close the poll and open up the results. All right, let's take a look at what the results are. All right, so we've got over half the people using DJI Others, so the Go, Go4, or Fly apps, very few people using Ground Station Pro, and then a similar number using Pix4D and Drone Deploy. And so this is interesting takeaways. I imagine DJI's large market share as, you know, the major drone hardware provider probably is why people are using their native app, but you get some great additional features with Pix4D and Drone Deploy. Again, we are not advocating for promoting any product here. Our comments are merely a reflection of what the majority of we see the industry use and also our customers are using. So helpful takeaways here. Okay. So for our last presentation, we're going to walk through a couple of example sites. I'm going to turn it over to my colleague, John, who's going to put it all together and apply it in real life examples. He'll take what David and Keith said and put it to the test. I don't think there's any better person than to walk you through this than John. As I mentioned, he's Scannfly's visionary. He's the founder and CEO, and he oversees all of the product development. John started his career as a PV designer for a commercial developer called GeoPeak Energy. In that role, his scope covered not just design, but most aspects of the solar project's life. He also worked afterwards at NRG, where he designed over 2,000 solar projects nationwide and became a leading voice on quality control for projects. After experiencing a lot of the inefficiencies firsthand that we know many of our customers have felt, he left to build Scannfly. John is OSHA and IREC trained and is a Part 107 drone pilot licensed operator. He also has a background in landscape architecture, horticulture, and GIS. So he's the perfect person to put all this together, whether it comes to vegetation or drones or solar. So I'm going to turn it over to John. He's going to share his screen. We're not all together because of COVID, but let me turn it over to him to get set up on his side, and he'll take it away from there. So John, over to you, man.
Okay, great. Thanks so much, Jason. All right, share my screen here. Great. Hey there, Scannflyers. Thanks so much for your time today. Okay, so, all right, before we dive more into those best practices when it comes to 3D mapping vegetation, let's first talk about photogrammetry. So what is photogrammetry exactly? Well, photogrammetry is the art and science of extracting that 3D information from photographs. This involves taking overlapping photographs of an object, structure, or space and converting them to a 3D model. For this example, the artist used an array of DSLR cameras and the photogrammetry method to create a 3D model of this race car driver. Pretty cool. Here's another example where the artist used the photogrammetry method to help design this World War I memorial in Washington, D.C., which I believe won the design competition and is scheduled to be built sometime next year. There's more information on the bottom left here if you're interested in learning more. So now if you look closely, you can see the soldier and the nurse in the memorial here. So, you know, why use this example? After all, we're not using an array of cameras. We only have one camera, and it's attached to a flying robot. So, you know, even though we only have one camera, the concept is still the same. We're using a batch of overlapping images to create a 3D model. So if you look at the array of cameras here, notice the cameras are positioned strategically at different heights and angles around the object that's being mapped. This maximizes the amount of coverage and ensures all areas of the object are going to be 3D mapped in the finest detail. So, you know, we're doing the same thing just with one camera, and we need to fly at different altitudes and position the camera at different angles to maximize the coverage and 3D map in detail as well. So this is called aerial photogrammetry, which is often used by surveyors and architects, engineers, PV system designers, contractors to create topo maps and 3D models, right? Meshes, point clouds, and drawings based on the real world. After all, at Scannfly, we're all about this real world context and designing and assessing our PV projects with the virtual replica of the environment. So now there's this method of aerial photogrammetry, and that's what I'm going to be talking about today. So now, before going on site, it's important to plan your flight before going on site. So always check your airspace and weather first before going out. Look at the satellite imagery to see what obstructions, like trees or power lines, are in your flight path. Look to see where there's a good place to stand, where the drone is still within line of sight. Also, what time of the day are you flying? If you're flying later in the day, try to stand farther west so you're not constantly looking into the sun when keeping an eye on the drone. Also, use the best app that works for you. There are a ton of apps out there, so use what you're comfortable with and what you've practiced with. Now, try not to upload images that you see here. When it's time to upload the batch of images to Scannfly, try not to upload the images that have the sun glare or the white balance issues. Sometimes the auto camera settings automatically adjust as you're flying because the lighting conditions can suddenly change. A good rule of thumb, always remember photogrammetry engines love consistency and high quality imagery. Okay, so now let's dive into the fun stuff. So in the Northeast, for this example here, homes are surrounded by trees. Homes that are surrounded by trees are pretty common, and not the greatest solar potential, but there is still some potential. So let's plan our flight just looking at the satellite imagery. We need a flight that's going to capture more of that surrounding environment. This is called that context flight, where you fly above all of the surrounding trees at about 100 feet or so. Sometimes it could be 70 feet or so, so 70 to 100 feet, depending on where you are, and keep that camera angled at around 45 degrees. Next, we want to capture the detail on the roof. So get really up close and personal with those obstructions. This is called the detailed flight. Fly around 10 to 20 feet above the roof ridge and circle those obstructions. Change the camera angle so it's more at 15 to 20 degrees or so. It doesn't have to be perfect, but notice how the flight path is inside of the space where there's no trees here. That's super important. So next, this is my favorite. Let's thread the needle. I personally love these flights. The main goal here is to 3D map the detail and areas in between the trees and the house. Fly the drone a bit lower if you can to capture more of the facade and the eave of the roof, and try the best you can to fly parallel to the perimeter of that building. Fly parallel to that facade there. Now, this is a manual flight that takes some practice, but the 3D model results are tremendous when you get this right. So let's check out the actual flight path here. Right, so here's our context flight, about 100 feet AGL, camera angled at around 45 degrees or so. Here's our detailed flight, nice and close to those obstructions. And here's our thread the needle flight. Not exactly parallel to the facade, but not too bad. This project was about 158 images, and here's the result. Let's let that load for a second. This is a really fun project. Okay, so this is a kind of a bowl tree example here, where you have the surrounding trees kind of has this cereal bowl effect. And notice, because we included that thread the needle flight, I'm just getting a 3D model here, you can see that the eaves have 3D mapped very well, and the facade along the back here. And there's a lot of detail in between the trees here and the facade. Okay, there's some detail here. And notice that the garage area did not 3D map very well. mainly because, and I'll go back to the previous slide here, the garage was not included in this image. So again, with photogrammetry, if the objects are not included in the imagery, it will not be 3D mapped. And this is a great example of that. And you can see the difference here. I'll load the save changes. In Scannfly, you can add your modules and perform your shade analysis here. Render those shadows. Really cool. Okay, so moving on to the next example. Okay, so in the Pacific Northwest, there are some very tall conifers that add an extra step to your flight stack. Now, there's a lot going on this site that needs to be 3D mapped, so let's go straight to those flight paths and call out each one. So first we have our context flight. Be sure to fly above those trees. If you can't see the top of the trees you're trying to 3D map, you need to increase your altitude. The next step is called the vegetation flight. Now, this is the extra step here where you need to identify those trees that need to be 3D mapped. In this case, we've broken these trees down into 4 clusters here. We're just going to map these 4 areas. The trees to the north will not be 3D mapped with the vegetation flight because they're to the north and there's no direct shade impact from those trees. So next are your detail flights. Again, getting close to those obstructions, circling them. Now, if you can't circle them all the way, it's okay to do a 180 there and just do kind of half of a circle. That's okay. Okay, so it's time now to thread the needle again, get in between those trees and the building there to capture the eave and the facade, just to capture more detail there. Okay, so this project has more images because we've included that vegetation flight in the mix there. So 333 images. This is a really cool project. There's a ton of detail here. The trees mapped pretty well. Let's let that load for a second here. All right, so check out that detail here with all of these trees. Really cool. There's a lot of detail when it comes to 3D mapping the eave there. I'll load these changes just to show the PV system on here as well as the shadow rendering. Cool, looks good. All right, so keeping an eye on the time here. So I know we've reached the hour mark. Apologize for that, but we have one more example to go through, and that's it. Okay, so the next example here, okay, is let's head to the southeast where we commonly see tree canopies that overhang on the roof. So for projects like this, the vegetation is too close to the roof sometimes to perform that thread the needle flight. So we need to take a similar approach here to make sure that our 3D model turns out just like this. And looking at satellite imagery, this image might deter you from 3D mapping the site. But don't be intimidated here. The solution is simpler than you might think. So yep, there's only two flights here for this project. So super simple. So let's start with the context flight again, and then followed by the detailed flight. So now this detailed flight, it's important to angle the camera down just a bit where you can we have the eave of the roof and in the area underneath of the canopy, the tree canopies here, where you're really capturing that and it stays in the center of the camera's frame. Okay, so this project was only 172 images. Let me load this one up here. Okay, you can see there's a ton of detail here underneath of the canopy, and you can still see that the roof eave has 3D mapped very well. So on this side of the property here, the roof eave did not map as well, and it looks like there's some room to do a thread the needle flight. So we would recommend flying a thread the needle flight here just to capture more detail and 3D map those roof edges there just a bit more. Okay, so I'm glad we covered all the bases here when it comes to 3D mapping vegetation. And with that said, I'll turn it over to Jason to ask our last final poll question and close out the webinar.
Awesome, thanks, John. So for our final question, we're going to ask the following, specifically for solar companies. Approximately how much time on site does drone surveying save you versus manually surveying a project, whether it's tape measure or going a ladder on the roof or writing it down on paper? We're trying to understand for those who are surveying with a drone or using a drone on site, how much time you're saving. Are you saving a 10% reduction in time, 25%, 50%, 75%, 90%? Are you not saving any time, but using a drone has other benefits that you're doing it for, such as safety, right? Staying off the roof, or do you not know? So give us a couple of minutes. Again, we know that we've gone over our timeline. Thanks for sticking with us, everyone. We're going to still do Q&A for the next 10 to 15 minutes or so. We're happy to dive into any questions you have. We'll do the poll, let's finish up, and then we'll do a Q&A. So Brian, if you see the poll slowing down, feel free to launch those results. Give it another minute or two. Okay, let's see what the results look like. All right, so, wow. So we've got about almost 40% say it's savings between 50 to 75% of the time. So we're cutting at least the time in half for most people. There's a lot of folks who don't know how much time they're saving, which I think is something that at Scannfly we're also trying to quantify. So I think an appropriate takeaway is that we assume or we know it will take time, will save time. Many people are confident it will save at least 50% of the amount of time. There's a bunch of people who aren't sure at this point. So it's unclear if they are not site surveying with drones or it just is unclear. I know at Scannfly we're going to be working a lot the coming months to further quantify this. So for those of you on the phone that have an idea, we'd love to talk to you. And those of you not, we'd love to figure it out together. So cool. Thanks, Brian, for helping us with that poll. All right. And next slide, John. Cool. So now we are going to jump into the Q&A. Before we get there, I just want to again thank HeatSpring, Brian Hayden and his team for hosting our webinar and for being our curriculum partner. They are a fantastic resource for a lot of different knowledge on things, especially in the drone department. So again, huge thanks to HeatSpring. And now let's turn it over to Q&A. Our team's going to share all of our faces, all of our presenters will hop on, and we're going to turn it over to questions. If you have questions, feel free to post them in the chat, and why don't we get to it? So one of our first questions is specifically, can you work off of a hotspot when updating a drone? So I'm going to turn it over to Keith to start. Can you work off of a hotspot when updating a drone?
Hi, everyone. Yeah, so the short answer is yes, but typically updating the firmware takes a lot of bandwidth. So if you have good service, then yes, but typically I don't recommend doing that. Try to do it at home beforehand. Check the morning of or the night before.
David, I know you've kind of gone to pretty rural and densely vegetated places. Any experience for you in doing this?
Yeah, if I don't have good signal, then I'm not able to do it off of a hotspot.
Okay, so it sounds like we should be wary of the hotspot and not take our chances. Cool. Next question, do you feel like the Inspire 1 platform with the X5 camera is still a good option? Keith, as our resident DJI dealer, I'm going to turn that to you. Do you feel like the Inspire 1 platform with the X5 camera is still a good option?
Yeah, I mean, there's a lot of elements to that question, right? So it depends on what you're using it for ultimately. But generally speaking, I think it's still a viable platform for most applications. It's hard to get batteries, it's hard to get propellers, and a few other things. But generally speaking, I think it can be a useful platform.
Awesome. John or David, any additional comments on the Inspire platform more broadly? No? Okay. Next question. Is it possible to integrate the 3D imagery from Scannfly software into PVSys as a shading scene for shading analysis purposes? I'll tackle this. And the short answer is yes. Scannfly is able to generate a DAE file and do that. We have another question here. How does one record a wooded site during the summer in particular, and achieve a 3D terrain model from a LiDAR capture image? So I guess I'll compact it here. And how does one record forestry using LiDAR capabilities? So I'm going to turn this one over to John first, and then I know, Keith, you've been looking into LiDAR recently. So just going to repeat it. How does one record wooded sites using LiDAR capture? So John and then Keith.
Yeah, great question. So in order to 3D map the area underneath of the canopy and just 3D map the terrain, that LiDAR-based 3D scanner needs to have the dual returns option turned on. So there's more there's more depth information that's being acquired underneath of the tree canopies.
Keith, anything to add on your experience with LiDAR?
No, I think John's more qualified to answer that question. But I mean, dense canopy in a, in the summer months in a wooded area, right, is a challenge. But yeah, I'm going to defer to John for that. Okay,
great. Next question. John talked about the thread the needle method. Is that done manually or automated? What are some other best practices? How do you also keep that in mind with different vegetation around and everything like that? So John, it was directed to you, and I would love for you to answer it. And then David, I'd love for you to jump in if you have any experience flying a similar method where you are.
Mm-hmm. Yeah, so the thread the needle method, that's a manual process, right? That's a manual flight. And, and as I mentioned before, it takes some practice, flying that drone side to side, keeping the nose of the aircraft and the gimbal, so it's perpendicular to the facade as you're flying to one side. So it does take some practice. It's a manual flight, but once you get it right, those 3D models, there's more detail that you can capture, and those 3D models really turn out really awesome.
Fantastic. Yeah, David, any additional thoughts? Please.
Yeah, I'd second what John said. And you're flying at a low altitude, and so you can basically, while you're flying that path, you can walk with the drone, and it's maybe 20 feet away from you. So it takes some practice, but you feel a lot more comfortable because the drone is low.
Mm-hmm.
Awesome, guys. We're going to stay in this department, following up on John's presentation. Half circle flights, in example 2 specifically, or let's broaden it, right? Half circle flights in general, are those okay? How do I know which part of the circle to fly? What is good overlap? If you can just dive into half circles a little bit further. Again, we'll do John and then David.
Mm-hmm. Yeah, so the half circles, they're not preferred, but if there's an obstacle in the way that's preventing you from going a full circle flight, then the half circle is the only thing you can do at the time. So with photogrammetry, you want to make sure that you capture all sides, if possible. If not, half of it is okay. Half of the objects that you're trying to map that's okay. But for a more fulsome 3D model where all of the sides of the object that you're 3D mapping are 3D mapped very well, then that full circle is needed. But half circle is okay if you just need one side of that object 3D mapped. Hopefully that answered your question.
Yeah, and I would just say that sometimes trees they'll overhang the house, and you can't do it. So, and oftentimes there'll be one tree that's overhanging the house, and in that case I'll do POI mode, get as close as I can to that tree, hit the X, put the drone back into hover mode, and then walk to the other side of the tree and then start again. And sometimes that's the best you can do.
Awesome. One more question in the department of flying methodology. In high vegetation sites, is it beneficial to capture the additional vegetation images, which I assume is referencing kind of the vegetation flights that, John, you talked about, those additional POIs, or just capture the large context flight? So I guess comparing, if I recall correctly, example 2 versus example 3. So just to reiterate the question, in high vegetation sites, is it best to capture the additional vegetation POIs or just do a large context flight, you know, and so therefore you have between 330 images or you know, sub 200 images? What is the best way? How do you make that decision? So I'll, you know, John again, and then David.
Mm-hmm. Yeah, it's a great question. You know, it depends on, you know, how much detail you're trying to map and how much detail you want included in your 3D model. You know, totally, you know, this depends on the site and, you know, with, you know, what you really want a 3D model of. With photogrammetry, it's always best to have, you know, more data than less when you're creating a detailed 3D model. But yeah, totally site specific there.
Yeah, and I would just echo the same thing. So I fly as a contractor for Scannfly. So I know when John and Jason are building the models, they want them to be as detailed as possible for their customers. So, you know, I'll do everything I can to make sure to get the most images that I can.
Awesome. We have a question here. Is Scannfly shade analysis validated? So we have been validated by a variety of state level regulators as well as lenders. And that's been the pathway for our customers who have specific needs. We also will work directly with them to get our features validated. So we have a ton of data and case studies supporting that information that puts us within approximately 1% of the sun eye. Obviously, the technologies are different, so there can be some variability. All right, let's look for some other questions here. We've got a lot more coming in. Is thermal imagery having the impact originally thought in solar, and where can we get training for effective settings and use? So I'll provide a high-level comment, and then I'll turn this over to you, Keith. Again, the question was regarding thermal imagery's impact on solar, and where can we get some additional training information? So I would say thermal is most commonly seen for utility scale asset management. We're seeing it be a great solution to cut down a lot of time for looking for electrical challenges on site, especially by identifying hotspots. There's a bunch of companies out there that do it, and we're seeing that it become increasingly popular both for annual or even more than annual O&M purposes, as well as when companies are buying or selling solar projects, they'll do that as a verification. So at a high level, it's being very popular. We actually have some of our customers who are thinking about it more for commercial size projects. Kind of a high level market comment would be that as the price of thermal goes down and the ubiquity of drones increases, I would imagine it becomes the standard for a lot of maintenance purposes. Keith, I know you're a thermographer and you've flown missions, so I'm going to turn it over to you to provide further color on the day-to-day and also where you can get more information on thermal.
Sure. Yeah, seeing it on the O&M side of commercial size operations, right? To do it on a residential application may not always be cost effective, especially considering the relatively high acquisition cost of thermal equipment and the drones to fly it. But it will be here more as prices go down. To get more information, I advocate anyone that wants to, really get into thermal and learn the science behind it. Take FLIR's class, become a certified thermographer. If you've got, other questions, I can do my best to assist, but FLIR's the expert in that. And if you really want to dive deep into it, that's the way to do it.
Awesome. Thanks, Keith. We had another question come up that was different than the ones we've had before, so I'd like to highlight this. The question reads, the New York Times article on July 23rd reported a cybersecurity concern regarding a DJI app. Can you speak to these concerns? Are there other flight apps that will work with DJI UAVs in place of the app in question? And then the individual cited the article. I'm not going to get into the politics or any of the geopolitical circumstances going on, but I'll make a high-level comment, which is, from our perspective, and our customers' feedback, we have not had any issues with DJI products. And that's just anecdotal from our customers and from what we've read in the market. I would say there are other options out there. I think we referenced Skydio and another individual in the chat before referenced Autel as other options. We are not advocating any products. Let me just be very clear. This is just what we know our customers use, what the vast majority of the market is interested in. So those would be kind of our high-level comments. Keith, I'm going to turn it over to you, put you on the spot if you have any additional color to add to the question or the New York Times article that the individual referenced on kind of DJI and cybersecurity concerns.
Sure, I haven't had time to adequately scrutinize the article or even read the article for that matter. So I can't speak to that too much, but I know there have been independent audits recently that have verified the security of the data from DJI. Now that being said, I mean, it's not an issue that I typically worry about, but you know, if you feel that that's important to you, it's important to do your due diligence and make sure you feel safe with that.
Yeah, and if I could add to that too, so with DJI apps, you know, just go into your phone, you know, and just adjust those permissions. So the app only has access to the mic and your camera roll and other things only when the app is turned on, and yeah, that should, you know, help with some of the security concerns there. DJI did launch a photogrammetry engine a few months back. That's a completely separate a completely separate item here, and the data that we're processing here at Scannfly is not using DJI's servers or photogrammetry engine. That is Scannfly. That is our own proprietary engine, and all of the data is safely stored. But going back to the app, just make sure that you adjust the permissions with the apps there, so they're only accessing certain things on your phone or your tablet when the app is turned on.
Awesome, John. Thanks for adding that color there. Yeah, great feedback, guys. We have time for a couple more questions. We see there's still more people on the webinar, so we're going to keep going for just a couple of more minutes. All right, just jumping around here. Doesn't the side sensor turn off in the POI mode with the Mavic Pro? So I'll rephrase the question, and then I think this one is for you, Keith. Regarding the Mavic Pro, does the side sensor turn off when you're in POI mode? Keith.
So initially, and now that the question was asked, I'm second guessing myself, so I'll confirm this. But initially, it did not, and I believe with a firmware update in mid to late 2019, it did. So yes, I believe it does work now, but one thing to say about the side sensors, they're not stereoscopic, meaning that it's only one. So if you look at like the Mavic 2 Pro, right? If you notice in the front of it, there's two sensors. And if you notice on the back, there's two sensors. And if you notice in the bottom, you know, there's two sensors. And the drone uses that for depth perception, right? Just like we have two eyes, it uses two sensors. And on a Mavic 2 Pro or Zoom, it's only got one side sensor, so they're not as good as the front and rear sensors. But go out and test it. You know, I've done it. I've used it, and I believe that it worked for me. But you know, confirm it, and I will verify.
Awesome. And again, if anyone has follow-up questions, we'll share our email afterwards, and we can circle back with any of the folks here. We're going to do just 3 more questions, and then we're going to wrap up. And so the next question we'll do is, how do you make sure your images look good before leaving the site? That's right, you've 3D mapped the site, you've surveyed it, taken a bunch of pictures. How do you verify those images? I think each one of you guys can definitely provide some color there. So why don't we go across David, then John, then Keith. Again, the question is, how do you make sure your images look good before leaving the site?
Yeah, so I guess I would say, you know, you just go into your gallery and review them. Oftentimes you want to make sure that the overlap is correct. And the biggest issue for me that when I review on site, well, I'll have to do an additional flight is roof glare or the sun glare being in the picture. So when you're flying, you're not necessarily noticing that. But then when you land and you look in your gallery and you can see that there's a big sun glare that really affects the images. So just reviewing them on the site is basically what I do.
Yeah. So it's helpful to view those pictures as they're being taken, right? So when the drone's in the air, right, keep an eye on that camera view to make sure that there are no white balance issues, brightness, and other things. Just to make sure that there's quality check in parallel to your flying. There's also after flying, check the gallery. Right? Those images are cached on your mobile device. Depending on the app you're using, but you could also check the images after the fact. But it's also important to be efficient and check the images and keep an eye on that camera as the images are being taken.
Yeah, all good points. I actually always bring a laptop with me when I'm on site, and I pop the SD card out, put it in my computer, and scroll through it. You want to make sure both A, the photos are in focus, but B, that they're properly exposed, and just do your best to look at them, and if you can obviously see it, there's big portions of the building and the house and the property that weren't photographed, fix it, but just take 10 minutes and look through them and make sure it seems reasonable.
Awesome. Next question, how does Scannfly produced imagery compare to LiDAR imagery? John, do you want to tackle this one?
Yeah, sure. So, there is no silver bullet to 3D mapping. Photogrammetry has pros and cons, and so does LiDAR. The future is fusing those two data sets together. And right now, the photogrammetry method is a high quality, very inexpensive 3D mapping method, right? That's really that's the way to go right now. In the future, right, when LiDAR, dense LiDAR data sets are being fused with photogrammetry data sets, that data is going to be, it's more dense, it's higher quality, and yeah, it's going to be just different quality there.
I'm going to add one thing from the accuracy side. Photogrammetry right now provides, we say near perfect accuracy. What that comes down to is roughly 2 to 3 inches across the 3D models, and that's not a Scannfly thing. That's driven by the consumer grade GPS modules in the drones. So when it comes to surveying tree vegetation, when it comes to capturing great accuracy for your solar project, photogrammetry is more than enough in almost every circumstance. Where our customers have seen challenges is if the trees are very thin. For example, there's no leaves, or they're mostly twigs, or the branches are thin, where there are other obstructions that are very granular in size. Similar where you need a survey grade analysis, that is another example where you might want to pay more for LiDAR if it's a larger project. But generally, the Scannfly produced imagery, as the question called it, or the photogrammetry method, will cover the vast majority of your projects and give you fantastic imagery and accuracy. All right, so last question, and I'm going to ask each person to comment, and I guess we'll start with Keith, and we'll work our way across the other direction, then John and David. The last question is, are there any specific settings in the apps that you recommend people turn on or turn off or adjust when flying complicated sites? And I guess we'll keep that complication directly specific to trees. Any settings that you recommend keeping on or off, whether it's exposure or interval or I don't know, you name it. But I'll turn it over to each one of you, and then we'll wrap up.
Yes, I guess so. I'll go first. My favorite setting is the vivid color mode in the camera settings for DJI Go 4. It really helps to make those colors pop and to help identify those key points from within in each image, and helps to create a better, higher quality 3D model with a more vibrant texture map in that 3D model.
Keith or David?
I like to use the histogram or the overexposure warning sometimes. I mean, if you're on auto, it's usually going to be properly exposed, but you know, experiment. And if you find you have a problem with something, you know, look it up on YouTube and then figure out how to fix it and then use that feature. But yeah, you know, for photogrammetry, auto is the way to go on my end.
Yeah, I just fly in auto, so nothing more to add.
Awesome. Guys, thank you so much for these answers. Thanks everyone for the questions. John, if we can just go to the next slide to wrap up. Just want to again give huge shout outs to HeatSpring, our curriculum partner, Hudson Valley Drones, and Keith and his team. You know, they are a fantastic drone pilots in the Northeast, and also our hardware partner. So if anyone has questions on DJI products, let us know and we can connect you over to Keith. And then last but definitely not least, David Williams at Northwest Drone Pros, fantastic drone business in the Pacific Northwest. And so if you anyone here from that area who needs help with drones, we'll connect you. So we just want to thank the three of our partners for really, really valuable feedback. John, next slide. And I guess we'll just close out by saying if you have any other questions, please email us directly. You know, we know we couldn't get to everything. Hopefully this was more or less exhaustive. We appreciate those who've stuck with us, but if you have questions for anything, please let us know. We are happy to have a dialogue and learn from you and learn together and continue to build the future of solar. So thank you everyone for joining us. Thank you again to our partners, and have a great rest of the week. And last thing to note, I guess, is, you know, we're hopefully going to have a survey and ask you for your feedback about what other types of webinars like this you'd like to see. We've got some ideas, but we'd love to hear from you as well. So hopefully we'll be in touch and continue to work together. Thanks, everyone. Have a great week.
Thanks, everyone.
Thank you.